Section 2.5, Application, Number Systems and Circuits for Addition. So here let's look at the binary representation of numbers. So again, binary, that's what computers use. It's also called base 2, and basically all of our digits are just 0 and 1. So let's look at how to take our first few digits in base 10 and write them in binary. So here, think of it as how many powers of 2 we've got. So if you look at 9, that is 1 times 2 cubed, plus 0 times 2 squared, plus 0 times 2 to the first, plus 1 times 2 to the 0. So we would write that as 1, 0, 0, 1. And you'll notice we usually put a little 2 subscript just to remind ourselves that these numbers on the right are in binary, so that we don't accidentally think that's 1,000 input. And just a quick reminder here of some of our powers of 2, because if we are using binary, these powers of 2 become extremely important. Well, let's try to go the other way. So this is a binary number, 110101. How do we write that in decimal? So I'm going to break it up each term. Remember that last term is 2 to the 0, not 2 to the 1. So since I've got 6 digits total, my first one is 2 to the 5th. And again, we're going to then just put a 0 or 1 in accordingly. And we can, of course, use our calculator if we don't remember what 2 to the 5th is. But here I would get 32 plus 16 plus 4 plus 1, and that does give me 53. They've also got a slightly different way to represent this same thing. So I might represent it a little bit differently, but the mathematics that I'm doing are exactly the same. All right, so again, let's go the other way. So now I have a number in decimal, 209. How do I write that in binary? Here is where it can be a little bit useful to have some of those binary numbers so I know where to start. And here, the largest number, smaller than 209, is 128, and that is a great place to start. So, and I'm going to use my calculator to help me out here, 209 minus 128 is 81. And looking here, 81 is between 128 and 64. And then I start pulling apart that 64. And if I keep going, I will get 128 plus 64 plus 16 plus 1. So again, I just want to know which powers of 2 do we add together to get that number. Again, we would then need to know that 128 is, for example, 2 to the 7th. And again, my calculator can help me with that if I forget that. So, as we can see, we're going to need 8 digits total. So it's going to be 1, 1, 0, 1, 0, 0, 0, 1. And there is that number written out in binary. Now, once we have numbers in binary, we can do addition and subtraction. It's going to be the same idea, but when we have a number that is 2, we are going to think of it as the way we did 10 in decimal arithmetic way back in like first grade when we first learned how to add. So let's take the numbers 1101 and 111 and add them in binary. So, again, if I'm adding ones like that, so 1 plus 1 in binary is 10. Similarly, 1 plus 1 plus 1, that's going to be 1, 1 in binary. And so here is how I'm going to set it up. So that 1 plus 1, I've got the 10 down here. You'll notice I've got the 1 up here in blue. That's my carry. And similarly, I will get the other numbers. And so I get 10100. And we can use a similar idea for subtraction, where we might have to do that same borrowing idea that we used in decimal. Here is an example in decimal, just to remind you how we did that borrowing technique. So, again, 10 minus 1 is 1, so we've got that same idea. Here I do have to do quite a bit of borrowing, and my answer is going to be 1101. And that is everything in section 2.5.